Hey, Miss Miklos here, and today we are learning about section 11.3, parabolas. And you guys might be thinking you already know everything there is to know about parabolas, and you would be half right because we know everything about one type of parabola, but we're actually going to learn about parabolas today that are not functions. Intriguing. So, our definition of a parabola is in a plane, the set of all points equidistant, which, yes, means equal distances, from a fixed line called the directrix and the focus. So, if I'm actually drawing out what this would look like, okay, here's my parabola. We have this line called the directrix, and we have a focus inside, and clearly mine is not to scale, okay? But what this is showing is that every point is the same distance away from both the focus and the directrix. And the good news is, to be honest, we don't really deal that much with the directrix or the focus, but in pre-calculus you will need to know that stuff, so it's good just to see that in our definition right now. So this general formula of y equals a times x minus h squared plus k should look pretty familiar to you guys. In fact, when we're graphing, we said we found our vertex by doing HK. We said that it was up if A was greater than 0. It was down if A was less than 0. It was fatty if the absolute value of A was less than 1. Remember, fatty fraction. It was normal if the absolute value of A was equal to 1, and it was skinny if the absolute value of A is greater than 1. Our fourth thing with graphing was our axis or line of symmetry. Which is a vertical line, which was x equals h. Okay, we actually learned all of this information back in chapter 5. Now, what we're going to see is we actually have a second type of parabola today that we're working with as well. And this general formula is x equals a times y minus k squared plus h. Our characteristics, once again, our vertex is going to be hk. But I just want to quickly point out, on our first equation, our y equals equations, notice h is in the parenthesis with x. That tells me that that value should be my x value in my vertex. In this equation, k is in the parentheses with y, which tells me that that should be the y value of my vertex. Instead of up and down, we know it's going to go to the right if a is greater than 0, and to the left if a is less than 0, which would make sense, and I don't know why I wrote a 3 there. Those are both step 2 there. Okay, the third characteristic is exactly the same. It is fatty, skinny, normal. And our fourth characteristic is our axis of symmetry, except for this time, it is a y equals line, which would make sense because we know the whole point of an axis of symmetry is that it has to go straight through our parabola. Our characteristics, and I'm going to squish this down at the end, we only have x squared or y squared. Okay, and that's how I can tell a parabola from our other types of conic sections. Okay, in my opinion, a parabola is the easiest one to differentiate because only one variable is squared. Every other conic section we have has both variables being squared. Okay, so one of the things we're really going to have to deal with today is figuring out which of these two formulas are we using and then finding all the appropriate graphing characteristics. Number 1, this should kind of be a flashback to last semester. This should be our favorite problem ever because, first of all, I can tell it's a parabola because I only have one variable that's squared. Notice my y is not squared. Secondly, this is already in our correct form. So the thing that helps me is I know that if y is our non-squared variable, I know that the y-axis goes up and down. Okay, and we can kind of see here the y-axis is going up and down. That tells me those are my only two options if it is a y equals. Okay, if we have an x equals parabola, I remind myself that the x-axis goes right and left. So that's how I remember which of my options I should actually use. Okay, so this is just something that helps me differentiate which direction our parabola should be going. So first thing I need to figure out, I'm obviously going to write parabola to begin with because that should always be our first thing. Okay, but I need to figure out my vertex. Now, if I'm looking inside my parentheses, I notice we have the x here. That means the opposite of this value is going to be the x coordinate of my vertex. And our constant is going to be the y value of our vertex. Since this is a y equals parabola, I know the y-axis goes up and down. A, which is 3, is a positive value, so we're going to say it's going up. Next thing I need to figure out is this fatty, skinny, or normal. 3 is greater than 1, so we're going to say that it is skinny. And our line of symmetry is going to be a vertical line because it has to go straight through our parabola. Our axis of symmetry is really going to focus on whatever's in the parentheses here. Okay, so x is in the parentheses, it's x equals -2 because that is the x value of my vertex. So if I'm graphing this, okay, I'm going -2, -1. Up in skinny, we talked about the fact that this is just a sketch. So I can just go up 2 and over 1 in both directions, and I am totally fine if you guys do that. If you wanted to go up 3 and over 1, that's fine as well. Okay, but this, more than any other graph, really is just a sketch. So you're just demonstrating that it is skinnier than if we just went up 1 and over 1 in both directions. Number 2 looks very similar. However, I notice all of a sudden that x is not squared. We only have one squared variable, so that definitely tells me that this is a parabola. And this is actually in the correct form, so I can go ahead and start figuring out our 4 graphing characteristics. This time, when I look inside my parentheses, I have a y. So I know that this number is going to be the y value of my vertex. Our constant this time is going to be the x value. Since I have an x equals, I know the x-axis goes right and left, so my x equals parabola is either going to the right or it's going to the left. Since it's a 3, okay, it is going to the right because 3 is a positive value. 3 still makes my parabola skinny. This time, my axis of symmetry, if we look inside here, it's going to be a y equals, and it's y equals -2. So if I'm graphing this, I'm going -1, -2. It's to the right and skinny, okay? So if we think about up and skinny, we go up 2 over 1 in both directions. If it's right and skinny, I'm going to go to the right 2 and then up 1 and down 1. Now, if the thought of drawing these non-functions freaks you out, here's my trick. We can always turn the paper and treat it like it is a parabola that's skinny that's going up. Okay, so if figuring out how to draw sideways parabolas confuses you, turn your iPad, turn your paper around. And I just want to kind of stress once again why this is not a function. Okay, and if I'm going, whoa, that's kind of a scary laser pointer. Woo, that's fun. Okay, anyways, if I'm going straight across here, as soon as I hit these points, I notice this is definitely not a function because I'm hitting 2 outputs for every input. We know each x value can only have one y value. But that doesn't change how I graph it, okay? So, key thing here, even though this is in the right form, we just need to be paying attention to what variable is not squared, okay? And that affects how we find our vertex how we figure out what direction it's opening, and what my line of symmetry is going to be. Now, unfortunately, number 3 is more like what we're going to be seeing. Okay, 1 and 2 were so nice and pretty because they were in the right form already. But number 3, first thing, I only have one variable that is squared. So that tells me that this is a parabola. What is different about this one is I have an extra y and a y squared. So the first thing that I actually want to do here is I want to go ahead and isolate our non-squared variable, which in this case would be x. So I want to get this x all by itself. So I'm going to go ahead and do two things at once. I'm going to go ahead and add x, and I'm also going to subtract 6y. Okay, so I have x equals, and I'm going to group y squared and negative 6y together. And then I have my minus 7 out and back. And I can definitely tell that this is not in the correct form. First thing we look for when we are trying to complete the square, do I have a leading coefficient that I need to factor out? In this case, I do not. So then I need to figure out what are we going to add to make this into a perfect square trinomial. So I'm going to take negative 6, divide it by 2, which is negative 3, and square it. So if I'm adding 9 to one side, I also have to add 9 to the other side. So I get x equals, when I factor this, it becomes y minus 3 squared. When I subtract 9 over, I get minus 16. Now, I don't really feel like being crazy and graphing this because of that negative 16, but let's practice finding our characteristics here. First thing, okay, when I'm looking inside my parentheses, I notice y, so the opposite of negative 3 is actually going to be the y value of my vertex. Negative 16 is going to be my x value. Since it's an x equals, I know my options are right or left. My a value here is a 1, so I know that that's positive, so it's going to the right. A is equal to 1, so that is normal. And my line of symmetry is going to be y equals 3, because y is inside my parentheses, and I know since this is a sideways parabola, a horizontal line would be what's going through the middle of it. Now, even though I'm not going to be totally accurate on my graph here because I don't want to waste my time, okay, let's pretend this is negative 16, 3. If I was going to the right and normal, I just want to stress what I'm going to do here. I'm going to go to the right one and then up one and down one in both directions, and then I would sketch my graph and sketch my lovely line of symmetry. Okay, so just to kind of recap, I could tell it's a parabola because I only have one variable that's squared. Okay, x is not squared, only y is squared. Secondly, I could definitely tell this was not in the correct form because I have this extra y going on. So we needed to isolate our non-squared variable, which in this case was x. Once I got everything over to the same side, I grouped my y terms together, and I went ahead and used completing the square, which we will use a lot this chapter. I figured out I needed to add 9, so I had to balance it by adding 9 to the other side. And then when I factored and subtracted 9 over, I came up with the correct form of this equation where we could get our characteristics and my lovely to scale graph. Number 4 looks really fun. Yes, that's a little sarcasm from me. But looking at this, I can definitely tell that it is a parabola because one variable is squared. We said that we want to isolate our non-squared variable. So this time, I think it would be easiest to do that by subtracting 8y. Now, logic would tell us, let's get it by itself. Let's divide everything by negative 8. And I'm going to hang on, and I'm actually going to make dividing by negative 8 the very last thing I do. Okay, the reason being, if I divide by negative 8, I'm going to deal with all these fractions over here. When I complete the square, I'm going to have to factor out fractions. It's going to be kind of ugly. Life is easier if this is together, and we're going to divide by negative 8 at the very end. Just trust me on this. So I'm grouping my x's together. And I need to figure out what should I add to make this a perfect square trinomial. It's nice because my leading coefficient is 1, so I don't need to factor anything out. So I'm just going to take 4, divide it by 2, and square it. So I'm adding 4, which means I'm adding 4 to the other side as well to balance that equation. When I factor this, I get x plus 2 squared. I need to subtract 4 from both sides. So I get minus 8 equals negative 8y. Now at this point, I have 1, 2, 3 terms. So I'm going to go ahead and divide all of those terms by negative 8. Now notice this allowed me to complete the square without having to deal with fractions. Now my leading coefficient here, my coefficient for that term is 1 over negative 8. So I'm going to write negative 1/8 times x plus 2 squared plus 1 equals y. Now this is in our correct form, so I can go ahead and list my characteristics. So we are going to say our vertex. Inside the parentheses I have an x, so that means that negative 2 becomes my x value, so negative 2, 1. Now I need to figure out y goes up and down because the y-axis is up and down. My a value is negative 1/8, which is negative, so it's going down. Negative 1/8 is also a fatty fraction, so I'm going to say it is fatty. And our line of symmetry is going to be based on x, because that's inside our parentheses, so it's going to be x equals negative 2. So let's go ahead and actually plot this on a graph. Okay, so here is our ginormous graph, and yes, I'm writing parabola in case we were unaware. So I'm going negative 2, 1. It's down and it's fat, so I'm going to go down 1, and then I'm going over 2 in both directions. I'm going to go ahead and sketch that. And then I'm drawing my line of symmetry, which is definitely not very straight on my iPad, but hopefully we can get the gist of that. So on every single problem on your homework tonight, I should see a graph, okay, and I should see our 4 characteristics on every single problem. Let's go through one final problem just to make sure we're feeling okay on this. And on to our last problem of the day. 2x minus y squared equals 0. Now, I can definitely tell that this is a parabola because I have one variable that is squared. It also looks as if I don't need to complete the square this time because I don't have an extra y hanging out anywhere. So, first thing I need to do, we said we always want to isolate my non-squared variable. So I'm going to just go ahead and add y squared over, so I get 2x equals y squared. So I'm going to go ahead and divide both sides by 2, so I get x equals 1/2 y squared. So at this point, this is actually in the correct form, and we can go ahead and find our characteristics. Now, y's are inside our parentheses technically, but I don't have anything, so I know that my y value is going to be 0. I also do not have a constant, so that means my x value is also 0. Since this is an x equals, I know my options are right or left. 1/2 is a positive value, so it's going to the right. It is also fat, so I'm going to say fatty. And our line of symmetry has to be y equals, because y is what is technically in the parentheses there, so it would be y equals 0. I really wanted to look at a problem like this because for some reason we tend to do pretty okay on difficult problems like number 4, and then all of a sudden we see something like this and we freak out. So I just want to remind us that when I don't have anything inside the parenthesis or when I don't have a constant, we know that they are just zeros. So now let's go ahead and graph it. Okay, so I'm writing a big fat parabola on my graph. And I'm going to 0, 0. If it's right and it's fat, I'm going to go to the right 2. I'm going to go to the right 1 and up 2, and to the right one, and down 2. My dots look awesome. Okay, so I'm going to go ahead and graph this and then draw my line of symmetry. So hopefully this is a good refresher for you guys on what a parabola looks like and how we find the characteristics. We're just adding in this extra layer of having to determine, is it an x equals parabola or is it a y equals parabola?